The basic gist of scientific notation is that we use it to write really big or really small numbers. Today we look at really big numbers. Because in our world of really big things or really small things, you don't want to sit there and write zeros forever. For example, our national debt or budget is somewhere in the trillions of dollars. Let's say our budget is $5,300,000,000,000. Okay. If you happen to be working with that number, all those zeros and all those digits get awful confusing. So one way we can make it less confusing and easier to work with is to write it in scientific notation. And the way that works is this, step number one, you need to move the decimal so that the number is between 1 and 10. Is that awful noise?
The car alarm.
Oh, was it? That was my phone. Okay. So right now, children, the decimal starts right here. That's where it is. You don't see it because we don't need it. If I were to move that decimal so that to make that number between 1 and 10, whereabouts would I put it? Andrew?
To the left one.
Now it's between 1 and 10. Now I just made it 500 or 530 trillion or whatever it is. This number is not between 1 and 10 yet. Where would I have to move it? Somebody help me out. Grace? Yeah, you'd have to take it all the way from here and move it to right here, because if you put the decimal there, now it's 5.3. Okay, really a good way to remember it is there should just be one digit left of it. That's not a zero. So this now becomes 5.3. Okay, you write any digit that's not a zero to the right of it. So I have to keep the 3. The zeros I don't worry about. Step number 2 is I write times 10 after that. And then step number 3 is you make the exponent of 10 however many places you move the decimal. Okay, which means if I started here, and it's a good thing I have commas, because each comma tells me I moved it 3 places. 3 places, 6 places, 9 places, 10, 11, I moved the decimal 12 places. That's the exponent that goes above 10, and this is in scientific notation. Okay. What it really means and why you can do that is, if you know anything about exponents and tens, what is 10 to the first power? 10 to the first power is, David? 10. 10 to the second power is 100. 10 to the third power is 1,000. Well, 10 to the 12th power, children, would be a 1 with 12 zeros after it, which would look like it's a 1 with 12 zeros after it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What I am saying in this scientific notation is I have a number that is 5.3 times 1 trillion. That's what 10 to the 12th power is 1 trillion. But rather than writing all that out, I just say I'm just going to leave my 10 with that exponent there. Because eventually we'll be able to do multiplication with that and division with that, and you don't have to write out all of these numbers here. Eventually. Not today. Maybe not tomorrow. Maybe not the next day. But at some point. No, we'll do it this year. So here's another one. What if I have this? 365,000. And I asked you to write that in scientific notation. It's a really easy process to do. I move the decimal so that it's a number between 1 and 10, which would put it where, Ryan Connor?
Between the 3 and the 6.
Yep. So it ends up being, you have to put all numbers that aren't zeros. So 3.65. I write times 10. And then how many places did I move the decimal from when it started here and got to right there? How many places is that, David? 5. And there is your answer. Now, do you suppose, in addition to writing things in scientific notation, there are times when we're going to have to go from scientific notation back to standard notation, our normal numbers. If I had 5.2 times 10 to the 8th power, and I asked you what standard, to write this in standard notation, okay, please understand this, everybody look up here, because this is the biggest problem I see with this. The answer to this is not 5.2 with 8 zeros after it. Okay, the answer is what happens when you move the decimal 8 times. So let me show you. Here's my 5.2. I need to move the decimal 8 places to the right. So if I do that, 1, 2, 3, 4, 5, 6, 7, 8. All of these little loops are zeros. I only actually have to add 7 zeros. One of those decimal spaces was taken up with that 2. Okay? And one of the jumps was taken up there, and then there's 7 more after that. So there's that moving 8 places. So my answer should be whatever, comma, 520 million would be the standard form of this scientific notation thing. Another one you say, of course.
Another one.
1.723 times 10 to the 4th power. And I asked you to change that into standard form. Did I get this stuff over here or not? I did. Good for me. 1.723 times 10 to the 4th. Again, you don't just add 4 zeros after it and call it a day. It's about moving the decimal 4 places. Okay, Brian, you end up with?
17,230.
Correct. Because you're going to go 1, 2, 3. You need to add a 0 in there, so it's 17230 pounds 17,230. Is there one up there? Is there?
There's that X in there.
There's a who?
Is that the X in there? 7.
What about this one, last one? What if I said to write 25 million in scientific notation? What would that look like? 25 million in scientific notation. Kaylee.
2.5 times 10 to the 7th power.
Let me write it out as 25 million. Yep, you move the decimal, so that's 2.5. You write down times 10, and you move the decimal 3, 6, 7 places. 2.5 times 10 to the 7. And you sound really smart, even though you're not.